Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by SUSE. My name is Cody, and I'd love to welcome you back to Techstrong Learning, where we do have an exciting conversation ahead. Before we get things rolling, we do have just a couple of housekeeping notes that I'd like to review with you. First, today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch or share with your team. You will be receiving an email with a link to access the recording shortly after we conclude this live session today. If you'd like to engage with us, there are a couple of options for you to do so. The first option is the chat tab, which you'll find on the right side of your screen. I'd like you to start testing out that chat tab for us right now by letting us know from where in the world you are joining us. If you have any specific questions, and this is kind of a fireside chat, so we're kind of leaning on you guys to help supplement our questions as well. Go ahead and send those into the Q&A. We want to keep them on the topic of cloud native platform engineering, but send in your questions and we will try to answer as many as we can today. So do so by sending those into that Q&A tab. Of course, before we close things out today, we are going to give away 4 $25 Amazon gift cards, so be sure to stick around to see if you're one of our lucky winners today. So our topic today, as mentioned, is cloud native platform engineering, and I'm joined by Ray Lejano, SUSE field engineer at SUSE. We also have Guillermo Martinez, founder at Techteak, who it looks like he's joining us a little bit late, but we will. There you are. Welcome to the show.
Here we are. Thank you.
Of course, glad to have you with us. And leading our conversation today is, of course, our very own Sharon Florentine, managing editor at Techstrong Group. So Guillermo, Ray, thank you both so much for being here with us today. Sharon, do you want to go ahead and get this ball rolling?
Yeah, absolutely. Thank you so much, Cody. And it's great to see you, Ray and Guillermo. I am excited to dive into this conversation. I know I just want to mention, in case folks were wondering, we have a slightly smaller panel than we expected today due to some unforeseen emergencies, but we are going to carry on nonetheless. So first, why don't we start out and have each of you briefly introduce yourself and tell us a little bit about what you do and your expertise in platform engineering. So Ray, you want to start?
Yeah. So hello, my name is Ray. I'm based out of the San Francisco Bay Area. I'm a field engineer with SUSE. So I primarily work on Rancher, which is a Kubernetes management platform. I also work in upstream Kubernetes. So I was the 123 version 123 release lead for Kubernetes. I was the emeritus advisor on version 125. I'm also a co-chair for the special interest group that runs the documentation for Kubernetes. I'm also a sub-project lead that led the external security audits for the Kubernetes project as well. I'm also a DevOps Institute ambassador. So that's me in a quick summary.
Awesome. Guillermo, welcome. Go ahead.
Thank you. Nice to meet you all. Hi, everyone. I'm Guillermo, background computer science engineer. I'm the former lead of DevOps and SRE in Accenture, the Netherlands. I recently opened my own company called Techteak, based in Europe. And I've experienced in platform engineering specifically with multiple clients that I've been helping them to move towards DevOps. And of course, platform engineering is one of the hot topics since 4 years ago. I'm talking about companies, big enterprises with more than 10,000 people that they really require a different approach, different from a startup in order to move forward. Platform engineering, of course, is one technique that we use. That's me.
Fantastic. Welcome and thank you so much. So let's start at the beginning. What are the origins of platform engineering? How did it evolve? And maybe just a brief history of platform engineering. Why did it come about?
I can go with this one.
Go for it.
First. Well, platform engineering as a term related to DevOps, as I said, started around 4 years ago. But if we think about platform engineering as the part of the people, being able to maintain all the systems, the servers, the infrastructure, all the domains, all the hardware, and certain tooling that we use when we talk about software development. Of course, it's way older than 4 years old. So we always have around system engineers and so on, operational engineers. However, at certain point, around 10 years, DevOps started, and all the teams were going with pipelines, automation, different toolings in terms of DevOps. At the beginning, everything was a little bit the wild, wild west. Everyone was doing the thing on their own. And while most of the time it worked well for small teams, small companies, small programs, this thing started evolving, growing and growing and growing. So we reached the point of we have multiple teams doing the same thing, having the same tools 20 times, 30 times, 40 times, having different tools that they do the same, no one really keeping an eye on them. And this is when platform engineering, at least related to DevOps, started to gain a little bit more traction and power. And this is where platform engineering started to get established, to try to bring a little bit of standardization within a large company. So everyone is using certain type of pipelines, the systems that we are using for that, they are all maintained, the toolings are all maintained. So the different teams don't really have to take care of the maintenance domain and things like that, so they can directly consume the platform itself. So more or less, that's the origin of platform engineering. Although if you look for that in internet, you have 20 different origins.
Yeah, you have
there is nothing really written on that.
Yeah.
I like to add that platform engineering also came about because people struggle with DevOps. Like sometimes there came to a point where organizations reach I guess a plateau with DevOps. The developers had too much cognitive load, where they had to build it, they have to run it, and sometimes it was too much. So I think platform engineering came involved to help take that cognitive load off those developers as well.
Right. It's Guillermo mentioned the standardization piece, right? So you're taking the need to, okay, we have to identify and then evaluate and then assess and then choose and then integrate all of these different things. It's like, nope, this is your platform and this is what you use. And now let's get on with it. Is that a kind of a lower level way to think about it?
Yeah, I totally agree that is a great lower level way to think about it. There might be some times where the platform may not satisfy all use cases, all developers, but it will satisfy most of them. And that I'm sure we'll talk about this later on about what's involved with platform engineering, where that you do satisfy most of your developers, most of your users.
Right. Okay. So as managing editor at Techstrong Group, I am responsible for more than two relevant publications here. One is DevOps.com and the other one is Cloud Native Now. And in putting together the topics and the questions for this discussion today, the question came up in my mind: is there an appreciable difference between platform engineering and cloud native platform engineering? Are those two things different? Are there nuances to the cloud native piece that we need to be aware of? Why is it differentiated that way, if it is?
It's your turn now, Ray, to start.
Okay. Yeah. So in the cloud native platform engineering. So let's take a look at cloud native itself. So cloud native is where you build and you deploy software that's appropriate for the cloud. And that also means most of the time containers.
Right.
And you're also microservices as well, where you take your monolithic application and you divide it up in independent microservices, where you could build, iterate faster and deploy faster as often. Most times you can have a CI/CD pipeline as well. So that's all lies with the difference of platform engineering and versus cloud native platform engineering is all the tools involved with cloud native nowadays. That's been that's, I don't want to say standard, but it's been very commonplace. Like where we see a CI/CD pipeline, but we also see GitOps as well. And that's part of that. We definitely see containers, of course, but it may not also mean Kubernetes. It might just mean any other container orchestrator. Kubernetes has become a de facto standard in the container orchestration world, of course, but it doesn't necessarily mean Kubernetes as well. So there are some differences in terms of how we approach cloud native itself, and that lies the roots of the difference of platform engineering versus the cloud native platform engineering.
Okay, yeah, that makes sense. Anything you want to add, Guillermo?
Yeah, I would like to add, of course, that sometimes what we see in companies is that there are two different teams, and for sure people in the audience, they will have a team for platform engineering, a team for cloud engineering or cloud platform engineering. I've seen it a lot of times, of course, that you have a team that they only maintain the cloud itself, but nothing else on that. There are pros and cons, to be honest, on that. So for instance, if you are running your platform of platform engineering in the cloud, but this platform engineering team are not the cloud platform engineering domain, then if something is wrong, they have to go to the cloud platform engineering and say like, hey, you have to fix this cloud so I can run the platform domain. So basically you are creating a dependency in that way. So yeah, in some cases we see the cloud topic, the cloud maintenance, and then the platform engineering more for the CI/CD and so on. So if you really have it split it and there is something not working, you have to go to the others to get you a hand. So as Ray was saying, for me, the best thing is to really think from a modern point of view, from a DevOps point of view, and consider like, hey, this thing goes hand by hand. There should not be really a split between them.
Okay. So that actually, I'm going to skip a question or two here because we have a great one that came in from the audience about the differences in skills between a DevOps engineer and a platform engineer in the cloud native world. Do we want to, let's address that now, and then we can get into a little more about the skills and expertise in general. So what are the differences between a DevOps engineer and a platform engineer, a cloud native platform engineer?
For me, in terms of skills, they are quite similar. A platform engineer will be a little bit more skilled, let's say, on the operational part. If we think about containers, Kubernetes, environments, cloud, machines, and so on, while the DevOps engineer will be a little bit more skilled on the software development, pipelines, so on. So the DevOps engineer should have knowledge in terms of containers, Kubernetes, infrastructure code, and so on. But on daily basis, he's not going to really apply this kind of activities. He's going to mainly help out a team to deliver everything. So he will be more involved with the pipelines and maybe a little bit the deployments and so on. But the platform engineer should ensure that this DevOps engineer can use the tools, can use all the infrastructure that he requires for deploying things. So as I said, in terms of skills, technical skills, they should be similar. So one DevOps engineer can move one day to a platform engineer, and the other way around, a platform engineer can move more into a DevOps engineer. The DevOps engineer is a little bit more focused on software delivery, while the other one is more focused on establishing that the entire infrastructure, the entire solution and tooling really are reliable and they work fine for the teams.
Okay.
Yeah, I totally agree. The tools and the workflows are going to be very similar to platform engineers and those. And yeah, like as Guillermo mentioned, totally agree.
Yeah. Okay. We've got some other questions. Just to acknowledge them, we're going to talk a little bit about SRE a little bit later, but I did want to ask and get into some of the general skills and expertise that someone would need to be successful in cloud native platform engineering. I think we touched on this a little bit when Ray was talking about Kubernetes and container orchestration, just cloud platforms in general. But anything else that you can think of, languages or go. I'll stop talking.
I don't know if I would. I don't know if I would say that they would specifically, if they're building the tool, of course, they would need to know specific languages. I find Golang to be pretty predominant in the cloud native scene as well. Not saying you 100% have to know Golang. Of course, there are a few emerging languages, so like Rust is coming up as well. WebAssembly, WASM, not necessarily a language, but it's also trending as well. So I would say you don't really have to know a single programming language. I would say you have to know the tools. You would have to be able to adapt to change quickly as well, because there are lots of change. The velocity of change in the cloud native world is very high. So the ability to adopt new tools, adopt new processes and workflows. One example is the whole automation of the CI/CD pipeline. There's lots of different tools for CI/CD pipelines. Argo is pretty much just the standard for that, but there's also Flex, and at SUSE we have our own project called Fleets as well. And then GitOps came about as well. So there's a big trend to use GitOps in your CI/CD pipeline. So I would say change, or the ability to adapt to change quickly, is a key factor. Not necessarily a set of tools, but of course the ability to use tools and understand containers, how to understand C groups, Linux, of course, would be helpful. Understand Kubernetes, but not necessarily you have to understand Kubernetes, but it's very common as well. Of course, be familiar with the hyperscalers, the big hyperscalers as well. It's just very common to see that out in the world. Not necessarily that you have to be familiar with them, but at least be somewhat familiar with them. So I guess that's those. For me, it's really about the ability to change in the platform engineering or in the cloud native sense.
Okay. Anything to add from your perspective, Guillermo?
Fully agree. We are talking about, when we talk about DevOps and platform engineering, software, cloud, infrastructure, automated delivery. So you need people that they really understand all the concepts. So we are talking about maybe a couple of programming languages. Personally, I love Java as a base, because it's quite complex, or C++, or some of these ones. And then some modern languages like could be Go, Node.js, because you see hey, the world has changed a lot, and then you see how it goes. Testing automation, testing strategy, how it works, and so on. A little bit of security. Infrastructure, both on the cloud and on premise, so you can play differently on that. And then if we go a little bit deeper, obviously, infrastructure as code could be Terraform, CloudFormation, Ansible, Chef, Puppet, things like that. So there is a lot of things to learn. Obviously, it's quite a lot of knowledge, without going and mentioning all the part of DevOps culture that is also important. Just to give you an example, if we go to the basics, we are talking about 2011, more or less. We were having Hudson. It was the former Jenkins. Mm-hmm. Well, then we had Jenkins, which was only graphic user interface. In 2 years, they changed it completely. So what you knew from Jenkins and how it worked, they totally changed it. And then you move into Groovy. Then from Groovy pipelines with code, they changed it again, and they released a new version. So I remember this time where you were using certain tool, and they were just changing it that fast that you have to relearn everything that you had. And of course, nowadays with all the DevOps tools that they change every couple of years, no more than that. Yeah, and what's something popular like Jenkins in the past is not used anymore, and then it moved to GitLab, and then it moved to Azure DevOps, and then moved to GitHub. Well, it's a constant change all the time. It's like non-stop of learning. Good thing is that it's not that complex to learn once you, as Ray mentioned, once you have this mindset of continuous learning.
Okay.
And a lot of the tools are open source as well, so it's available for you to learn.
Excellent, an excellent point. A couple things that came in from the audience. Let's see. I'm sorry. I'm gonna scroll back here so I am sure that I'm getting this right. What are the differences in skills between? Oh, we already covered that one. I'm sorry. I'm repeating myself. So what's the difference between platform engineering, SRE, and DevOps? How we kind of covered platform versus DevOps, but SRE hasn't really come into it quite yet. So maybe we talk about that now, since that's the second SRE question. How does SRE tie into this conversation? What do SREs do? What is the practice of SRE, and how does it relate to cloud native and cloud native platforms?
Yeah, I can go with that. Well, I would say, of course, SRE, DevOps, platform engineering applies better in big enterprises, in large companies. Because if you are really in a startup, you don't need to have that many roles or that many different domains. It's more like a jungle, and a single person can do almost everything. However, when we talk about a big company, you might have people that they really focus on the software delivery, the team's stability, ensuring that the software that the team is producing goes farther and farther and farther, and they can continue working. That will be the more role of a DevOps engineer, who is a little bit more embedded into the team. This team is consuming certain pipelines, build servers, Sonar, for instance, different tools and different software as a service solutions that they are using. This is the platform engineer role, to keep everything stable, to run these kind of platforms, to ensure that when I want to run my Sonar Cube analysis, Sonar is stable, Sonar runs there. But then you have SRE. SRE is the point of you have to ensure that everything runs well in production. Your applications run well in production. They go a little bit more to the extreme, even attacking themselves. So they are the ones who are trying to bring down all the servers that we are talking, not only the platform engineering servers, but all the servers that we have in the company. They are trying to tear them down. They are finding ways to programmatically create all the environments and all these kind of things. So an SRE person is the role that ensures that what you have as an application, as a product, it runs properly in production. And that's not the role of a platform engineer. The platform engineer is only a role for ensuring that the delivery, the continuous delivery, works fine.
Yeah, I would like to say that SRE is like kind of like the operations folks that now we just kind of changed the name from ops to SRE, and so they may make sure whatever the workloads are, they have to run and running. So they might be Kubernetes admins as well, to make sure that the platform or Kubernetes is ready to run their workload, and also the underlying infrastructure as well.
Okay. Yeah, the uptime considerations, right? Making sure that you're taking error budgets and uptime and downtime and SLAs and all of that good quality of service kind of stuff. All right, let's see. I know we are getting all kinds of amazing questions here, so pardon me as I move over here from my previously scripted questions, and we'll try and make this a little more ad hoc. Someone brought up service mesh as a tool that's important in the practice of platform engineering. We have seen much more interest in an adoption of service mesh just over the last, 12 to 18 months. How is that impacting platform engineering? Why is it becoming much more necessary? And this person mentions Istio and Tetrate as two of the big ones. So maybe we can talk a little bit about service mesh and how that meshes with
Yeah.
this? Pardon
So-
my pun.
So folks who are not familiar with service meshes, it's another layer above, let's say, the container Kubernetes layer that controls service-to-service communication. It might be usually over multiple Kubernetes clusters or multiple places where your containers are running. I would say that we're seeing it quite more because from what I've seen from Service Mesh, the more mature organizations are with their containers and Kubernetes, the more they have requirements for that satisfy as what a service mesh would require. And service meshes could do all sorts of things, like they could provide ingress gateways, egress gateways, TLS for your applications, and so whatever the use case, I just see lots of organizations maturing to a level that they would require a service mesh, and that translates to platform engineering as well.
Right. Okay. Makes sense. So if a person wanted to build all of these skills for themselves, how would they go about starting to pull this expertise together? Where would they go for training? What kinds of courses and topics would they get into? Like, if you're just starting out, how do you get into cloud native platform engineering?
Great question. Actually, I had a webinar. I ran a webinar last week that was about that, about how to move into what is DevOps nowadays, which is kind of like the de facto standard. I think, let me go even into the file, then I can even share it with you guys. From my point of view, first you need to have the basics, understand what is DevOps, what is platform engineering, what is SRE, how the software development change when we are applying DevOps. Because sometimes what I've noticed is that even people that they call themselves DevOps engineer or platform engineer, they really know nothing about DevOps. And that's a pity because it also changed in the way we work. So I will start with the basics, understanding the basics of DevOps, for instance, a little bit of Agile as well, platform engineering, what is infra as code, how these things are changing, cloud basics as well. It's totally, I mean, they are really two worlds when you compare on-premise versus cloud. It's really like, it sounds like the same, but the way you manage infrastructure, it's totally different. And I've seen a lot of times people that they're trying to manage cloud as it will be a traditional on-premise servers, and that's really a big issue, both from the management point of view, but operational point of view. So starting with that, with this small learning, that's a great thing. Then I would go with a little bit more the cloud fundamentals, could be AWS, Azure, or GCP, just to start learning a little bit more. And then, as Ray mentioned, it's open source. Most of the tools are open source. Best thing is to really create a hello world and start creating yourself certain pipelines that can deploy and deliver everything automatically, so you get the content. And then look for a little bit more training, more information on how you can grow up. But as I said, you have programming, testing automation, configuration management, infrastructure, monitoring, containerization, Kubernetes. It's really an insane amount of load. So without, for instance, a background in computer science, getting that knowledge can be quite hard. I mean, it would be really a nice adventure, a nice journey, but it would be hard. So, but again, I would say start with the basics, foundational level, understand what is what, because from there, your brain is going to start changing and it will start identifying new things to learn.
Yeah, totally agree. I mean, there's so many places that offer cloud native fundamental courses. We have one on containers and Kubernetes. It's totally free as well. Your hyperscalers will have them as well, as Guillermo mentioned. So there's lots of places to start with, and then really get your hands into it. Like actually use your command line tools to actually run instead of taking these classes. That's where you would actually really absorb the information. I like to point out too, there's also from the Cloud Native Computing Foundation, there's a maturity model that they've released. It's really more for organizations But if you look into more of they have a section under technology, so you can understand what in the high level, what organizations are doing in terms of like the automation, their CI/CD pipelines, or orchestration, and cloud deployment as well. So there's all these like free resources from the Cloud Native Computing Foundation, the DevOps Institute as well, that is available for folks to use. But definitely start off with the basics. You don't need. What if you're familiar with containers, which is totally fine. So you might want to move on to Kubernetes or the different CI/CD pipelines that are available as well. So there's lots of different sources as well. So it's really just actually going out there and trying it out and launching some of your VMs on your laptop to try it out.
Yeah. All right. I'm just looking through these questions to make sure we don't miss anything over here. So if you are at an organization and you want to start evolving toward a platform engineering practice, how would you start that initiative? How would you put that together?
So I would start with treating the platform as a product first. So in terms of that, you would have a product manager as well. You would go through interviewing. You would have a roadmap. You would interview your users. But in this case, your users are your internal folks that are developing on top of your platform. So I would treat it as a product. I have a roadmap and goals for that product. I like to mention, I think there was a few questions on DevOps and platforms as well. I like to say that the platform engineering platform team prepares a platform for developers. These are like the tools that developers would use. Developers build on top of that platform, and DevOps gives that structure for their work. But in terms of back to platform engineering within the platform teams, I would start off with treating your platform as a product internally, meaning product manager, product owners, or stakeholders. And as a product, it will also have software engineers as well that will build your tools. We'll have end users, consumers, and those are your internal developers. So treat it as a product.
Okay. And this is where you had mentioned earlier, you're never going to please all of the people all the time, but you can please some of the people all of the time, or all of the people some of the time. So how do you come to a consensus about the specific tools that you're using for this platform? Just a simple vote, or are there integration considerations, or what do you consider?
Yeah, it's prioritization of those requirements. So as a product, you would have a requirement stock, or you should establish a requirement stock, what your platform should do.
Okay.
Prioritize the needs of your users, your developers. I also like to do a lowest common denominator tech stack as well. So meaning that you are going to use the easiest technology to build your platform and optimize against it. So that usually means containers for most folks, and that's just the very foundation of it. So it could go anywhere from there. So in terms of trying to satisfy most of your users, you would have to prioritize and also iterates as well. So you would interview your users on ongoing basis, have a change requirement stocks with new releases, and prioritize.
Okay. Thank you for clarifying that. So one of the motivations for platform engineering in general is that it frees up developers to have more time to innovate and deliver a better customer experience, whether those customers are internal or external or wherever they are. So how does platform engineering do this specifically? And tied into this a little bit is, do you have to restrict platform engineering only to the largest organizations, or can it deliver those benefits to smaller ones as well? So I know that's like 6 questions in one. I apologize.
No, but it's really linked to each other. So yeah, I got the point. Well, first starting large organization versus small organizations. A small organization can have a platform engineer that will be responsible to ensure that the entire delivery good is quite smooth without any problem. Most likely, if the company is a startup and so on, he can do more than that because it's not going to require that much time. I mean, at the end, it's not that complex when we are talking about a couple of applications and small teams. So there is not that much change. So that person can do something above of the platform engineering role he's doing. When we talk about large organization, enterprises, and so on, now it changes a little bit more because we have way more consumers of the platform itself. So the platform has to be a little bit more stable. We are talking about a lot of other applications. For instance, in my client, we are talking about more than 5,000 applications. So when you have a platform engineers maintaining everything, hardly ever they have time to do something else. Well, of course, obviously, DevOps and Agile is to speed up and deliver value faster, as you were saying. So the idea, the intention is that as a developer, the end goal is I write my code, I push my code, and I forget about what happened next to that. I don't have to go and start checking if this is properly configured, if the server is not running well, if I have to change this or that. No, I just write my code, push my code, and then automatically I can see that up and running in a test environment or even in production if I want. And that's the goal, of course. If you give that to the developers, if you give to the developers the power of writing the code, pushing, and not having problems, so the code goes up to production, and in case there is something to fix, they are automatically informed about, hey, your code that you just wrote, there is a couple of bugs here, so fix it before you move it forward. Well, you gain a lot of speed. You gain insanely amount of speed in that sense. So that's the goal, obviously. The platform engineer has to ensure that this automated delivery end-to-end works fine. And again, when we talk about large organizations, that's really full-time job, and you need a lot of platform engineers. When we talk a small company, medium-sized company that has lower teams and the things are a bit more stable, there is not that many things up and coming. Well, they might have a little bit more time and they can even participate in the software development, for instance, or other activities.
Okay. So obviously AI, generative AI, this is all, every headline lately has some mention of AI or generative AI. So how does that impact platform engineering and cloud native platform engineering? Does it just kind of accelerate everything, or are there, things that we're not really seeing yet?
You go, Ray. I have. I love AI. I'm mentioning.
Okay, go ahead. Go ahead.
Well, for me, the first time that I spoke about AI in the world of DevOps was like 7 years ago, and I was saying that always when giving trainings and so on, I was saying like, of course, you have the waterfall delivery that you only see value after a certain amount of months. Then you have this short waterfall, which is what we call nowadays agile, but still is most of the time waterfall, that you see value a little bit earlier on time and so on. Then you have agile, that you really see the value every iteration, and then you have DevOps, that you really see the value in a constant manner, really exponential. The next to that is what I was saying, like AI together with DevOps. And what I was meaning with that is not what people might think about the toolings, that they can understand what are the problems and so on, and they can predict issues. No, I was thinking about how if you can reproduce customers with AI. So you know what the customers want with AI. So before you are really implementing things and before you are really giving your solution to the real world, and then you don't really have insights until you have thousands of customers, you can reproduce them with AI. That was something that I was speaking about, as I said, like 7 years ago on that. And for me, this is really the power of AI in this part of DevOps and so on, because it can reproduce customers. It can tell you what the customers want without even having the customers in front of you. And then, of course, if we go more into the tooling and so on, to be honest, AI and machine learning has been already used there for some time ago in the different tools. They are able to help you to predict when something is going to fail. They help you to predict when there is going to be really a need to scale up all the systems and so on. So, of course, that's quite useful, more technically speaking.
That's actually what we're doing at SUSE. So there was a comment to DevOps and AIOps/MLOps. That's actually what we're actually doing, AIOps, MLOps. So one of our projects that it's open source, so but we do plan to GA it later this year. It will learn about it's for Kubernetes. It'll learn about all your Kubernetes logs, your metrics. So it will tell you should you're using this much resources, you might want to scale up, or it will warn you before your application actually goes into failure. So it'll learn about your application, learn about your Kubernetes cluster, learn about the underlying infrastructure itself, and it'll warn you before anything actually happens. So that's what we're implementing with AIOps and MLOps here at SUSE. So that's one of our projects that's related to Kubernetes, and that'll be available for anyone since it is open source.
Cool. All right. Well, let's see. Let me just take one last glimpse through audience questions. And if we did not get to your question, we are going to send these over to our panelists, and they will be able to respond to you. We've got one, AI modeling costs. How much do you need for your... I think this is probably a offline question. It's talking about AI modeling costs and availability of data to make reasonable predictions from that. Unless one of you wants to tackle that now, I'm going to hand it back to Cody, who I believe has some information about Amazon gift cards, among other things.
I sure do. Thank you, Sharon. And Ray, Guillermo, thank you both so much for joining us today. Guillermo, I know I didn't get a chance to speak with you much before we went live today, but I'm very, very happy you were able to join us today as well. And Ray, thank you so much for being here as well. I did want to remind everyone that this session today was recorded. You will be receiving an email with a link to access the recording on demand. Or, of course, you can find this recording living on not only the DevOps website, but also the Cloud Native Now website. So feel free to check out either of those, and you'll find these webinars living in the on-demand section. The 4 winners of our $25 Amazon gift card drawing, they are Cynthia S., Enrique A., Faith H., and Olga S. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. It should make its way to you in the next 48 hours. If you don't happen to see that email, check your spam folder just in case it happens to be filtered out. I'd like to thank SUSE for sponsoring our program today. And to everyone who is still with us, thank you so much for joining. I do want to ask you just for 1 minute to fill out a brief post-webinar survey that will pop up on your screen. I've also just posted it in the chat. But we do want to hear your feedback, whether it's about today's program or if you have suggestions for a future topic. Please let us know there. Either way, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day. And Ray, Guillermo, Sharon, thank you all.
Thanks a lot. Thanks to you.